Okay, this is the first of 2 units that we're going to look at, which is going to cover repetition in Java. So everything that we've done so far has basically covered following a set of instructions step by step, one after another. We've used decision statements in the form of if statements, which will give us one or two or even multiple routes through code, but what we've not done yet is look at sections of code which repeat themselves multiple times, and it's one of the most important things that we need to learn about in programming, because that's what computer programs are actually very good at, in that they can repeat the same code lots and lots of times. And we do that with the use of loops, and the type of loops that we'll be looking at today will involve the use of conditions, and we covered the majority of the work on conditions in the last lecture. So today we're going to look at the structure known as a while loop, and the while loop that we're going to look at today is what we call a precondition loop. Now, precondition means that the actual condition is at the beginning of the loop. There are types of loops known as post-condition loops, where the loop condition is at the bottom of the loop. We're not going to look at those in this particular lesson. We're just going to look at the while loop as a precondition loop. And with while loops, the condition is set such that as long as the condition is true, then the instructions inside the loop will continue to run. And when that condition becomes false, we then escape the loop. We're going to have a look at a little example. Let's say we've got a method in Java, and we're going to add the value of 10 to an instance variable 5 times. Now, based on everything that we've done so far, that is effectively the way that we could do it without knowing how we construct loops. You probably, saw that, and straight away you thought it was quite an inefficient way of doing it, mainly because we're repeating the same code one after another. As it says there, it's inefficient. What if we wanted to have a set of instructions that added 50 numbers, 100 numbers, 1,000 numbers? No one would be in a position to copy and paste that code that many times. So clearly there's a need for us to understand the implementation of Java loops. In terms of the previous example, if we repeated those two statements 5 times in a loop structure, we would only effectively need to write the code for the loop and those 2 lines. So as a maximum, you're probably looking at 3 lines of code as opposed to 10 lines of code. So before we look at the main structure of a while loop, we need to sort of look at some of the bits that go into a loop structure and understand how they get stitched together. So think about having a measure or a count, which will count how many times we want to go through that loop. So if we have the variable and call it count, we can use that to initially start it at 1, so that's the first time we go through the loop, and we want to keep going as long as that value of count is less than or equal to 5. So 1, 2, 3, 4 and 5, and that's our 5 iterations through the loop. Every time we go through the loop, we add 10 onto that number, and then eventually we want to output that number. And once we've done it the first time through, we add 1 onto count, and then we'll go back and repeat as long as the value of count is less than or equal to 5. So again, we add 10, output the number, add 1, so count will be equal to 2. Go round, 2 is still less than or equal to 5, add 10, output the number, add 1 onto count, count's equal to 3, and so on and so on and so on. This is a typical while loop structure in Java. And this is the code that we would effectively write to basically install that loop. We have our count variable, which we initialize to 1, and then we've got our while structure. So while the value of count is less than or equal to 5. Now obviously when we first hit that condition, the value of count is 1. So while 1 is less than or equal to 5, we add 10 to the value of number, output the value of number in a user.message box, and then add 1 onto count. So basically the next time that we come round from here, count now has a value of 2 because we've added 1 onto it. 2 is less than or equal to 5. We add 10 on, display it, add 1 onto count, so count is a value of 3, add 10, display it, add 1, count is a value of 4, still less than or equal to 5, add 10, display it, count as a value of 5. Count is equal to 5, so we add another 10, display it, count as a value of 6. 6 is certainly not less than or equal to 5, in which case at that point we skip out and we carry on outside of that loop. Let's have a look at that. Okay, so I've downloaded the program while count from the VLE, just compiled it. So let's have a look at the code in the editor. And again, it's a reasonably straightforward piece of code. We've got our class definition for while count. We've got one instance variable for mNumber, and we initialize that to 0. Our repeat test, which is the main method, we have a local variable called count, which we use to keep a track of our count inside the loop, and we set that to 1. So while the value of count is less than or equal to 5, add 10 on, display the value of mNumber, and then add 1 on to count. So the value of count, while this loop goes round, will be 1, 2, 3, 4, 5, and 6. When the value reaches 6, 6 is obviously greater than 5, and then it should escape the loop. What we'll do is we'll close that up and we'll create an instance, and then we'll just see that working. So we'll just inspect it, and let's just call repeat test. There's the first element of mNumber, count equals 1, count equals 2, count equals 3, count equals 4, count equals 5, and then count equals 6. 6 obviously is not less than or equal to 5, and in that case then we escape the loop and the method closes. Okay, so let's just take some of the more important points out of that demo. First of all, we've got to make sure that we set up our counter variable before we get into the loop. Alright, we're going to look at a couple of examples in a minute where if we don't do it properly, it's going to cause you problems. Obviously, everything that you want to repeat, you put inside the loop. And anything inside that loop will be repeated as long as that condition is true. Okay, and again, we need to be careful about that condition. It's important that we worry about that condition and make sure that that's correct. Otherwise we end up with problems with things called infinite loops, which you're going to have a look at in a minute. Because if you don't, that loop will never stop repeating. And again, it's called an infinite loop. So have a look at that program. It looks very similar to one that you've just looked at, but there is something inherently wrong. Okay, again, pause the video if you want and try and think about what's wrong with that program. Okay, the issue is all to do with this count. At the minute, we set the value of count equal to 1. While the value of count is less than or equal to 5, we add 10 onto it and then display it. And because these values in here are repeated as part of the while loop, it'll come back round and it'll say that the value of count is less than or equal to 5. Well, count will always be less than or equal to 5 because the count is only added up outside of the loop on the other side. So count effectively stays at 1. So you're almost infinitely going to keep adding 10 onto the value of m number, and then you're going to display it. So again, this is one of these things that you're going to have to be careful of when you're setting up these while loops. Okay, have a look at that one. Again, examine it, pause the video if you want, and just think about what the problem is with what's going on in that particular loop. Okay, in this particular example it seems to do everything right. We've moved that count away from outside of the loop here and we've put it inside, so the value of count gets incremented. We add 10 on, we display it, we add count up, it goes round, but it's all to do with what's going on here. We initialize count and we set it up with a value of 10. Now the condition in the loop hasn't changed. We've actually said that while the value of count is less than or equal to 5, but we've initialized the value of count with a value of 10. So as soon as we hit this condition the first time through, the value of 10 is not less than or equal to 5, in which case the flow of the execution of the program will hit this condition. That condition will then be false because 10 isn't less than or equal to 5, and then the flow of execution completely bypasses all this code that we've written and it'll continue outside. We'll come back to methods in a minute, but one of the things I wanted to sort of show you is another addition onto the use of the user class. And one of the things that we're going to look at is taking user input. We've not been able to do that. I mean, for some of the examples we've had to call methods to add values on or take values away, and really we could do with the way that we could input values through the keyboard. One of the reasons why I've left input at such late stage is because we can actually use our input along with a loop in order to create basic data validation, which is basically forcing people to type things in correctly, and we won't carry on until they type things in correctly. What we're going to do is use another method that's inside the user class in order to demonstrate that. And you again have already used the user class before, and you're perfectly used to using user.message for output. You certainly know how to call the message method as part of the user class, and you know how to put strings into the user.message class in order to create prompts and output data and join things together by using the plus symbol. We're also now going to introduce you to another part of the user method, which is called input int, and it does exactly as it sort of describes, whereby it will allow the input of an integer value in a pretty input box. Those of you who have done Visual Basic before will know already about the use of an input box. I think it's called, the command is called input box, and it's very similar to that sort of command. And the way it works is that you have a command, user.inputInt. Don't forget you'll have to include the user class as part of your project. The prompt in this bit is basically a string. Please input your age or please input a number. And the value that you type in will be stored in a variable. So we type something in using user.inputInt and we store it in a variable. Okay, let's have a look at a really basic example of that. Okay, I've downloaded the program input test from the VLE, give it a quick compile, and let's just open it up in the editor and see what it looks like. Okay, we've got our class called input test. It's got one integer variable called mValue, and in the constructor we initialize it to 0. The only additional element is a method called ask4value, and this is where we show you the use of user.inputInt. This is the prompt part, so basically that's what will be displayed in the input box. This is the command to call the code for an inputInt box in the user class, and the value that gets typed into that input box gets stored in the variable mValue, which is our integer. So we'll give that a quick compile and we'll create an instance, and then we'll inspect it, and then let's call that ask4value method, and straight away you should see similarity with, for example, a VB input box, where that's the prompt and it gives us the opportunity to type a value in. Let's say 20 for an integer and click OK, and the value of 20 gets stored in mValue. So if you take on board what we've just demonstrated and think about how we could incorporate the use of a loop, and then look at the example that we talked about earlier about inputting values and adding them up consistently, we can sort of merge the three elements together and create a simple loop that will allow us to input 5 values, total them all up, and then display, for example, the grand total at the end of it. So again, another little exercise for you. I've put together a piece of code that we've looked at before, but what we need you to do is to modify that so it allows 5 values to be input from the user and then output the result of the whole thing. So effectively we're modifying the loop slightly, although we don't need to change the loop itself because we're adding 5 values. Instead of adding 10 onto the number, what we want to do is get 5 values which are obtained from the user. So we need to use user.inputInt at this point. We will need to add the value that's typed in from the user onto a running total. We'll still need to increment the value of count for the 1, 2, 3, 4, 5 value as we go around the loop, or count up the number of times we're applying the loop or going around the loop. And then potentially we could sort of use a user.message outside that will allow us to view the grand total. So again, pause the video. A couple of ways you could do it. You could jot it down on a bit of paper, or if you're feeling brave enough, just try creating it in Java. You've got all the bits. Maybe roll the video back, take all the bits that you need, and try building a little Java program and see if you can get it working. And what we'll do is we'll demonstrate a working version. Okay, so I've downloaded the program whilecount2 from the VLE, and I've just compiled it. So again, let's just have a look at the code in the editor so we can break it down and see how it works. Okay, so our class is while count2. We've got an integer instance variable called mNumber, and in the constructor I've initialized it to 0. We've got one method called addValues, and inside addValues we've got two local variables. We've got count, which is used to keep a track of the count or the number of times that we go around the loop. We've got userVal, and userVal we use as the integer variable that's going to store the number that the user types in from the input box. We've initialized count to 1 because we should always initialize the count variable before we hit the loop. And then inside the loop, where the condition is while the value of count is less than or equal to 5, keep doing everything in here. In which case, we ask the user to enter a value that we need to add. We're using a user.input box, and the value that we type in gets stored in userVal. We say let mNumber equal mNumber plus the value that we've just typed in. So mNumber is effectively the running total, and we add our last typed in number to mNumber, and then we increment the count so that we can go round the loop. And count in the first instance will be 1, then 2, then 3, then 4, then 5. It will add one on for 6, but then 6 is not less than or equal to 5, so we'll skip out of the loop, and then we display the grand total after that. So what I'll do is we'll compile it and run it, and we'll do it with simple numbers like 1, then at least we can easily work out what the answer should be. So we'll create an instance and we will inspect it just so we can see what's going on, and then we'll call addValues. First time round we'll do 2, second time round 2 again, third time round 2 again, that's 6, fourth time round 2, which will be 8, and fifth time round add 2, which should make it 10. And because we've come out of the loop, because the value of count was equal to 6 and we've escaped, the value of mNumber is equal to 10, and that gets set inside the variable. Okay, so let's develop this a little bit further. At the minute, the loop that we've generated, we know how many times we're going to go round, because in our condition we've said as long as the value is less than or equal to 5. Well, if you're only adding 1 on to count every time, straight away we know that when the value becomes 6, we're going to escape out of the loop. But what we can do is we can almost get the user to enter as many values as they want. We could say, how many values do you want to type in, and store that in a variable, and then use that variable to control the loop. So if we ask the user how many values do you want to process, and you type in 10, then we can process that 10 times using the same loop. Another way that we can do it is by not having a question which asks them how many times they want to do it. Let's make the user do it as many times as they want, and when they've finished, get them to type in a dummy value. It's sometimes called a sentinel value. So as an example, if they're typing in rainfall values or something like that, then what you can do is force them to say, well, type in the rainfall values that you want to type in, and then when you finish, type in -1. And we know -1 is a not particularly sensible type of value for rainfall, but we know, or we could get the system to find out, that when -1 has been typed in, we know that they've finished typing in the data that they need. So let's just think about that in the context of the program that we've just written. What we're going to do is we're going to set up a user val, and that's going to take the value from user.inputInt. So what's going to happen is we're going to get the first value before we even hit the loop. Now that's a weird one, and students often ask a lot of questions about why we do that. But if you think about why we do it, it's actually quite straightforward. Because we haven't got a count variable, because we're not counting how many values we're typing in, we're actually getting the user to type in as many as they want until we type in a dummy value. We have to get the first value off them before we hit the loop, because potentially if the first value that they type in is -1, that means they've finished. There are no more values to enter. So what happens is, for example, if we type in this line here -1, so user val has -1 in it, and then we say in the condition at the top of the while loop, while user val is not equal to -1, well, user val is equal to -1, in which case we then hit the dummy value first time round and we can completely skip the while loop. It's an extreme test, but potentially it can happen. In the majority of cases though, what we do is we type in our first value, could be 10 or 20 or anything, as long as it's not -1, and then we say while the value of user val is not equal to -1, then we get the first value that we typed in and we add it on to the running total, which was number. We've added that value in the running total down here, and then this line is a repeat of this line, but it's stuck within this while loop. So we ask for the next value, store that in user val, and then we come back round the loop and test if it's not equal to -1. If it's not equal to -1, then we can add it on to the running total. If they've typed in -1 here and they come back round, we know that we can come out of the loop, and any previous values that have been added in, we just display them in a user.message box. And let's have a look at that working. Okay, so I've downloaded the program Lec5A from the VLE. Give it a quick compile. So let's have a look in the editor. And as you can see, we've got the class Lec5A. There's one instance variable called mNumber, and we initialize it to 0. And then again, our add values has been slightly amended to incorporate this repeated loop. We have userVal, which is used to store the values from our input box or inputInt box. We type it in first time round and store it in userVal. While that userVal is not -1, then we add the last value entered into the running total and then ask for the next value. What can happen then is that we go back round to the while loop, and if that last value typed in is not -1, we can add it on to the running total and then ask for the next one, and that will carry on forever and ever and ever until at this point here we type in -1, where the condition at the top of the while loop will trap that, we escape the loop, and then we display the running total, which is the value of mNumber. So we can test that, give it a quick compile, and let's try it out. We'll create an instance and we'll inspect it, because we always inspect our programs as they're running, and then let's call add values. So first time round, and remember we've got no count, so I'm just going to do it in tens, and I'll put 5 in or 6, and then we'll do the dummy value. So 10, 20, I'll do 10 again to make it 20. 10 again to make it 30. 10 again to make it 40. 10 again to make it 50. And this time round we'll put in our dummy value to escape. And it comes out of the loop and it tells us that M number is equal to 50. Okay, one of the common usage of that sort of setup that you've just seen is to allow us to perform a very basic form of user validation on values that get typed into our programs. A good one that we can talk about for that is if you're asking for a number that's within a particular range, for example between 1 and 10 or 1 and 100 or 10 and 20, and we can basically ask the user for a number, and if it's not in the range that we want it to, we can basically put a while loop in there which will force the user to input the correct value in the correct range. Otherwise we won't carry on with the rest of the program. And precondition loops, which I've mentioned before, are a good way of doing it, because it does exactly as I've just said. It forces the user to type in correct input, otherwise it just won't carry on. And there's a sort of pseudocode semi-Java based example here. Some of the lines don't stretch across single lines, so I'll sort of apologise if they don't sort of meet along single lines, makes it a little bit more difficult to read, but I'll explain it anyway. Fact of the matter is that we've got a user.input int again, which asks for a value between 1 and 10. So the user will type in a value, an integer, and it's stored in value. But we've got a decision, and it's a compound decision which will generate true or false, as all while loop decisions do. But in this case we say while the value that's been typed in is less than 1, or the value that's been typed in is greater than 10, we force another input because they've not been able to type in a number between 1 and 10. We want something from 1 through 10, not less than 1 or greater than 10. So we ask them to type it in again, and it gets stored in value. It comes round the loop again, and if the value that's typed in here is less than 1 or greater than 10, we get them to type it in again, and that could carry on forever until that condition is met. So let's have a look at that in the context of our vending machine example. Okay, so I've downloaded vending machine 5 from the VLE, compiled it. Let's have a quick look at the code. And there's actually not a vast amount that's changed from the previous ones. We've still got our constants for crisps and chocolate, and the maximum number of packets in the machine, the maximum number of chocolate bars in the machine, our twice price markup. We've initialized the crisps and chocolate bars in the machine and how much profit we've made, and we've actually put our validation into the fill crisps and fill chocolate bars methods. I'll do it from the fill crisps perspective. The chocolate bars works in exactly the same way, but what we do is when we fill the machine with crisps, we only have so much room for so many packets of crisps. In fact, what we've got is a constant called max packets, and in our max packets we set it to 10. So that's the maximum number of packets of crisps that can be added to the machine. It's not a very big machine, but what we need to do is work out how many packets of crisps we need to put in the machine to fill it up. So what we do is we have a little local variable called packet space, and we take the max packets, which is 10, and we take away the number of packets of crisps that are already in the machine. So for example, if you've got 3 packets of crisps in the machine, we can't put 10 in because there won't be enough room. So we take the number of crisps in the machine away from 10, which gives us how many we need to add. In which case, if there was 3, that'll be 7. We then ask the user how many packets need to be added. And we say, while the number of packets is less than 0, i.e. they've been daft enough to type something in like -4, or the number of packets that we want to add is greater than how much room there is. So for example, if I wanted to add 7, but there's only enough room for 3, then 7 is greater than 3, in which case I'm not going to let you add that many. So we're going to say we can't enter that many, you're going to have to type another one in. It will keep doing that until you type in something reasonable, in which case it will then add the number of packets in and then adjust the profit accordingly. That also works with chocolate bars, but instead of max packets we use max bars, which I think is 10 again, and it works in exactly the same way. So let's have a quick go, and we'll create an instance and we'll inspect it. But what we'll do is we'll be a little bit more careful this time when we're examining what we're actually doing. Now obviously we're starting off with a completely empty machine. So what I'm going to do is I'm going to fill the machine with packets of crisps. And the first thing it's going to say is how many packets need to be added. Now there's only room for 10. So I'm going to start off by typing in something stupid like -4. And it tells me I can't enter -4. So I'll add 15. And again, 15 is greater than the maximum number of packets. And again, it says I can't enter 15. So I can only add as many as there are spaces available. So let's fill the machine up. And clearly, it shows us that there are 10 in the machine. To make this more realistic, I'm actually going to sell 2 packets. So I'm going to buy 2 packets of crisps. So we've got 8 in the machine. And now I want to add 2 more. I want to fill the machine up again. So what I'm going to do is I'm going to call fill crisps. And it says how many packets do you want to add. Now clearly if we've got room for 10 and there's 8 in the machine, we know that there's only enough room for 2. But if I try and add 3, it tells me I can't enter 3. So I have to enter 2 to fill the machine up. And it's added the 2 packets, which has gone back up to 10. So we know that that little while loop is actually doing what it's supposed to. Okay, so let's just summarize everything that we've done. First of all, we've had a bit of an introduction to using loops. The main loop that we've covered today is the precondition loop in the form of a while loop. While loops have a conditional statement at the beginning, hence the reason why it's called a precondition loop, and the loop will continuously run as long as that condition is true. As soon as that condition generates an overall false, it will then escape the loop. We can set up a while loop in 2 ways, either with a finite number of iterations using a count, or we can set it up so that it will run almost an infinite number of times with a condition set up within it so that it allows us to escape from the loop. We've done that by looking at the use of the input int method of the user class, which allows us to obtain integer data values, and we use that to allow us to now write programs which allow us to type numbers into our programs.